Hey everyone, my name is Sally Ann and I'm one of the product leaders here at Arize. I'm really excited to walk you through homework assignments 1 and 2 for the AI Evals course. Over the next 15 minutes, we're going to cover how to write and test system prompts, generate synthetic data, annotate traces, and identify common failure modes using an LLM. Before we dive into the assignments, I want to quickly introduce you to our two main products at Arize, Phoenix and AX. These two products work together but serve slightly different needs. Phoenix is our open source, self-hostable, and extremely customizable product. It's designed to meet developers where they're at. So whether you're working in a local Jupyter notebook or deploying in your own cloud environment. It's great for running evaluations, writing prompts, and digging deep into your application's behavior. And then we have AX, our enterprise platform that supports evaluations at scale. I'm talking billions of records backed by ADB, the Arize data backend, with SSO support, advanced observability, and team collaboration features. Whether you're a small team running heavy workloads or a large org with production deployments, AX gives you everything you need to develop, evaluate, and observe LLM applications at scale. So today I'm going to be using Phoenix to do homework assignment 1 and 2, but towards the end, we'll talk about how AX could help you complete these with the help of powerful tools like Alex, our AI agent that we've built into the platform. But with that, let's get started. So over here, I've got our code for our first homework pulled up, and we're going to be focused on system prompt engineering. So the overview of this assignment is to write an effective system prompt, expand our query dataset, and set up Phoenix for testing. The first few cell blocks here are just for our imports. We're going to want to make sure everything's installed and ready to go, and doing things like enabling nested async for our notebook. And then we're going to want to get Phoenix up and running. So I'm using Phoenix Local to complete these assignments. You could opt to use Phoenix Cloud. The only real difference here is maybe grabbing your API keys from the platform if you're using Cloud. But if you're using Local, which I suggest you do, it's really easy to get started and you have a lot of control when you're running the application locally, is you can either run this code that I've included in the notebook or go ahead and run this from the terminal. And then once you do that, Phoenix will be running on localhost and we'll be good to go. So we have Phoenix set up, great. Now let's do our prompt management. We're going to create a really simple prompt at first. I created something really basic here. I'm just basically telling it what its job is, which is to create recipes and cooking advice and provide it in a clear step-by-step instruction. This is a baseline prompt to have a good starting point that we can start testing and understand how it's performing. So I'm going to go ahead and log this to the Phoenix platform just by giving it a name, a little bit of description, and I can also log any model parameters that I want, like name. And this is really helpful for when you're maybe iterating over time. You might be experimenting with different models. We're going to be able to track that by each version that we create. So I went ahead and ran this, and then if we pop into the UI, you can see that it's been added. We've got that system prompt along with the model configuration, and from here, we're pretty much good to go. So Phoenix supports full prompt management, so you'll see as we iterate, you can see all the saved versions and have that full control. Let's go back to the code. Let's create some data before we do our actual prompt iteration piece. Now, the homework assignment comes with a sample of 3 queries. So just a quick vegan breakfast recipe. I have chicken and rice, what can I cook? And give me a dessert recipe with chocolate. But the assignment calls for us to expand by adding 10 more queries to this data set. I added 10 additional queries manually, and then I'm just going to go ahead and load that into the Phoenix platform. And if we pop over here, we can see that we've got that total of 13 rows available for us. Now, if you wanted to, you could add the examples in the UI and just upload the CSV, kind of completely up to you. I like to do it in code to make it really simple. So awesome. We have a prompt loaded to start with. We've got our sample data set. Let's go over to the prompt playground now and actually do some testing. So let's go ahead and load in that prompt that we've created and our data set. And I'm just going to go ahead and change our prompt variable. I'm using fstring here, and I want to make sure that the prompt can actually pick it up. So we've got everything all set up. We don't have to do any of this in code. We can just now run the prompt, and Phoenix is going to run it on each of the examples. And it's also going to track things like latency and token count and cost for us as well. So we can kind of see how that compares prompt to prompt as we iterate. But it's also doing an experiment for us. You can see here it says view experiment. So It's going to track experiments automatically so we can easily compare outputs across the runs. So it's generating as it's going. I'm going to go ahead and start reviewing some of these results, and let's see how our first basic prompt did. So first question is just a question asking about how we store herbs. Overall, looks like it's giving some different ways that a user could store them with some instructions. So overall, nothing really shouting at me. Now, looking at this example here, it does seem like the format from the first to the second is slightly different. So usually you want to make sure you have a really consistent user experience. So that might be something that we want to keep track of and iterate. This one too, again, super short. We're seeing such variety in terms of output. The other thing that I'm noticing is there's a little bit of a lack of a personality. The bot's just kind of responding. It's not really asking if there's any kind of follow-ups. And sometimes it feels like it's being either super specific or a little bit more general. So I think I need to give it some personality, and I think I need to give it clear instructions on how it should be responding and exactly what styling it should include. So what I'm going to do is I'm actually going to go ahead and push compare. And what that's going to do is add an additional prompt to our playground. And why this is so powerful is now I can go ahead and take two prompts side by side, run them on the same data set, and be able to compare how they are performing and how they're differing. So this is going to be really great for your iteration workflows. I'm going to go ahead and pull in a prompt that I already kind of set up for us here and pop it in to the playground. So let's kind of at a high level understand. So right away, this system prompt is a lot more detailed. It's explaining what the core responsibilities are, outlining what the guidelines are for ingredients and instructions. It's giving it a little bit of a personality and saying what it can and cannot respond to, as well as the style formatting. Those are going to be really key when you're creating a good system prompt, is you're going to want to make sure you're explicitly telling the LLM what to do, what its responsibilities are, and how it should respond. And what we'll see as we run this is hopefully now that we have added in all of those additional requirements, we're going to start getting more consistent results and better outputs. So we're seeing the results come in, and now let's start doing some comparing. So taking a look at these results, the first ones seem pretty comparable, but you'll definitely notice that a lot less text. So at the beginning I was saying it's very wordy, and now I feel like, okay, maybe we're getting a little bit more consistent results there. You can also see right away that the formatting from the first to the second is consistent versus before, where it was a little bit inconsistent with how it would present. Even for things like the general questions versus the recipes, you can see that that formatting is really consistent. I'm also seeing that it's having a little bit more personality. It's stating why it's picked a recipe, or kind of at the beginning. You see here where it says it's renowned for its rich flavors, understanding the spices can help your cooking. So I think all in all, we were able to really improve our results by adding in these additional responsibilities and the instructions here. So what I can now do is go ahead and save that. It'll go right as part of that initial version. And if we go back to our prompt over here, what you'll see is we'll now have an additional version available to us. All right, so now that we have our prompt, we're ready to move into homework number 2, which focuses on generating additional data and doing more systematic analysis. So we're going to do this in 3 parts. The first part is going to be focused on generating synthetic data. Second, we'll run that prompt that we just created on all of those new queries. And then we're actually going to annotate the results and try to identify where there are maybe failure patterns. We'll then generate our taxonomy for our failure modes so that we can understand what those common failure points are. So step 1, of course, is just going to be to set up our imports. I'm then just going to get my OpenAI key set up. I'm using that for the synthetic data generation, but you can, of course, substitute that with any model provider that you'd like. Now let's get into the data generation. So the first step of this is identifying key dimensions. So the assignment asks us to create 3 to 4 key dimensions relevant to the functionality of the recipe bot. Now, I'm going with dietary restriction, cuisine type, meal type, and skill level. You can, of course, adjust these to be whatever it is that you would like. Now, This is going to give us hundreds of possible combinations. You can see here I've created 450, but we're going to use that to then create unique combinations. And to do that, we're going to just grab 25 of those 450 and we're going to create these. So you can see here are some examples as we're just kind of grabbing a few combinations of those. And then once we have that, we're actually ready to do the synthetic data generation. And the way we're going to do that is actually using Phoenix's LLM generate function. And I really want to highlight why using LLM generate is so powerful. And it's really because it handles all of the messy orchestration. Async calls, retries, rate limits. It's going to work directly with the data frame and templates. So you just kind of pass it those dimensions in a prompt, and it's going to give you the structured results without any extra parsing. So it's just going to make this process way easier for us than if we were going to write this all from scratch. So I'm going to take those 25 tuples that I've created before, I'm just pretty much formatting it into a data frame, and then I've created this prompt for our generation. And then once we do that, we can just go ahead and pass that here. And in the end, we're going to get some different query outputs. So we've got our 25 diverse synthetic queries, so we're good to go there. We just got to get them into the platform. So again, we're going to go ahead and run our upload dataset call to get that loaded into the platform. So back in the UI we go, just to double check on those data sets. You can see that it uploaded here. Let's test it in the playground. So I'm just going to load that data set into the playground. I'm going to go ahead and choose that prompt that we just created. You'll notice that it automatically pulled in the latest version for us. And all we have to do is run it. And I mentioned before, an experiment is going to be automatically created for us. So let's go ahead and take a look at a few of those now. So going ahead and looking at these, what we want to do now is use the free text annotations to form the basis of our error analysis. We want to review each output, noting where the prompt didn't meet our expectations. So we don't want to simply just say wrong, we want to describe the issue. Like the user asked for a quick recipe, this recipe is requiring something that takes a lot of time. So let's go through a few of these now. This is a great example. So as we're looking through this user asked for an advanced vegan lunch that captures the essence of American cuisine. So right away looking at this, they asked for something vegan. I'm noticing that there's heavy cream and parm, definitely things that are not vegan. So what we can do here is type in the notes that say, ignores dietary restrictions. And so we don't really want to say again that this is wrong. We're trying to explicitly explain what it is that is wrong. So we can kind of continue to go through, and what we want to do is essentially continue to try to identify areas where perhaps the application got it wrong. So I've kind of gone through and annotated the full data set. So let's go back to our code to finish off our assignment. Great, so now that we have all of our data annotated, we can actually go ahead and export that data back into our notebook so we can start creating our taxonomy. So I'm just going to go ahead and export that data from the platform. And you can see here, we get our free text annotation in our results.explanation file here. And so what I'm going to do is, rather than sitting here and kind of combing through all of the explanations and trying to come up with patterns myself, I'm actually going to use an LLM to do it. So I'm going to go ahead and create a simple chat completion, and I'm giving it a prompt with all of the data, and I'm just asking it to come up with some labels that represent the data that it's seeing. And so what we're going to get is a list of our labels, with each data point being a failure mode. And what we can then do is use LM generate again to label each data point with the corresponding failure mode. And then once we get that, we can kind of analyze to understand exactly where the most common failures are. And we're actually going to save this off for use in a future assignment. And so that's going to be homework assignments 1 and 2. To summarize, what we did today is we wrote an effective system prompt. We did that by iterating on the platform. We built a synthetic data set, and then we were able to create a taxonomy using annotations from reviewing the underlying traces. Well, we used Phoenix today. Everything we did can also be done in AX with additional enterprise features. Alex, our AI assistant, can generate prompts and data directly in the UI, and we also have LM as a judge evaluation that can run in the playground as you're iterating. So you can get a free account today and start exploring these tools. In assignment 3, we're actually going to use AX directly to scale these workflows. So this wraps up our walkthrough for homework 1 and 2. Hopefully this gives you a strong foundation for using Phoenix for prompt-based evaluation and trace analysis. Feel free to reach out to me or to our community if you have any questions, and I'll see you in the next one where we dive into AX. Thanks everyone.